All right, our second topic in the exponents unit is negative exponents. So for negative exponents, it says for every non-zero number a and integer n, a to the negative n equals 1 over a to the n, and 1 over a to the negative n equals a to the positive n. So think of the negative exponent relocating the base to the other side of the fraction bar. And when this happens, the exponent becomes positive. So let's look at some examples of this idea of negative powers. And I want to rewrite my answers to have a positive exponent. So in number 1, we have 3 to the negative 2. And our property says that if I move this to the other side of the fraction line, so you can think right now it's in the numerator. If I move it to the denominator, I get 1 over 3 to the positive 2, which is 1 over 9. In number 2, so I'm going to move 8 to the negative 1 to the denominator. I'll get 1 over 8 to the 1, or you could just write that as 1 over 8. Remember, any number or variable to the first power is just itself. Number 3 will become 1 over negative 5 squared, which is 1 over 25. And number 4, we write this as 1 over negative 3 to the positive 3, which is 1 over negative 27. Just some properties of exponents and variable expressions that you need to write down. In algebra, an expression in simplest form only has positive exponents. If a factor in the numerator of a fraction has a negative exponent, take it to the denominator and make the exponent positive. And if a factor in the denominator of a fraction has a negative exponent, take it to the numerator and make it positive. All right, a few more examples, simplifying with negative exponents. So keep in mind our final answer has to contain all positive exponents. So if there is a factor with a negative exponent, just that factor is going to move. So in number 5, I notice that 3 and y have positive exponents. So they are going to stay where they are in the numerator. The x has a negative exponent, so I'm going to move it to the denominator, and that 2 will become positive. And that's my answer. In number 6, so let's draw a fraction line. The x has a positive exponent, it will stay where it is. Y has a negative, so it moves to the denominator. And remember, anything to the 0 power is 1, and 1 times x to the 6 is just x to the 6. So that's my answer. In number 7, let's see, the 4 has a negative exponent, so move to the denominator. The x has a negative exponent, so it moves to the denominator. Y has a positive exponent, so it stays where it is. And z has a negative exponent, so we move it to the numerator. Okay, last 2 examples for this topic. It says solve each expression for x equal to 2 and y equal to 3 and z equal to negative 2. Well, first thing I'm going to do is rewrite my answers so they have positive exponents. So here I'm going to rewrite this as 3y over x to the positive 2. Now I'm going to substitute in where y is 3, so we'll have 3 times 3. And x is 2, so we'll have 2 to the 2. 3 times 3 is 9. 2 to the 2 is 4. We get 9/4. Same thing in 9. I'm first going to make my exponents positive. So that means z will come to the numerator, 4 and x will go to the denominator, and y to the 0 is just 1. Now let's substitute in. I get negative 2 over 4 times 2 to the 3rd. Order of operations, so we'll have negative 2 over 4 times 8, negative 2 over 32, which reduces to negative 1 over 16. Okay, go ahead and try the practice sheet on 0 and negative exponents.